Okay, in the lab, we missed one function. Okay, so after the crossover and the mutation operation, we needed to update so far the best solution and objective. So we let the register prepare this function for us. Okay, so what you need to do is look through objective array for parent and children. Right? Okay, and then find the iteration best solution ID. First, check whether its value is better than the current best objective, right? If it does, then update the best objectives and do gene-wise copy the iteration best chromosome to so far the best solution. Okay, so what you need to do is that you look through all these objectives and find, suppose this one is the iteration best. Then, because this value, if this value is better than current value, current so far the best, if this better is better than current so far the best objective, then replace the so far the best objective with this iteration best. So suppose this is iteration best, and then do the gene-wise copy from this iteration best chromosome to so far the best solution. Okay, you should be careful. You are not going to just copy the reference into this reference. You need to do so-called gene-wise copy. Alright, so this part has been missing. Alright, so during this computation, probably we needed to recall what? Recall iteration average and the iteration best objective value, right? So because that is for charting purpose, we need to draw 3 lines. One is the so far the best objective so far the best objective value, right? So we still need another, we might call it double iteration best objective, and we also needed to carry the iteration average. So these data and as well as the so far the best objective were withdrawn on a line chart to indicate the convergence tendencies for our GA evolution. So we need these two values. So basically what you need to do is that, well, I put in here calculate iteration-based objective. So that gotta be an objective of one chromosome. Either it is on the parent or on the children. Calculate iteration-based objective, and then also calculate an iteration average objective. So you need to calculate these two values first. So if the iteration-based objective is better than so far the best objective value, right? We update the base solution and objective values. Otherwise, we simply calculate these iteration objectives and iteration average objective. So that will serve as the data required for our charting. Okay, so up to this point, I think everything is okay. But initially, because if you want to make a comparison, right? Initially, the objective value, so far the best objective value should be set, right? Because we need to update the so far the best solution, right? So we should, during the reset, we need to set the so far the best objective value first, right? And then later on in the first iteration, it will be replaced by this function. So let us go back to reset function. So reset the iteration ID and also if optimization type equal optimization type maximization, then so far the best objective value equal double dot minimize value, else so far the best objective equal double maximum value. Yeah, that's it. So during the first iteration, then it will be overridden by the first solution. Okay, by the first iteration. Okay. So that is the job. Update so far the best solution and objective. So you needed to check the objective value, and you needed to identify whether it is maximization or minimization to do the correct calculation. Okay. All right. So let us take a look at the UI requirement. So definitely we will need what? We will need property grid, and also we will want to draw these three lines. So during the computation after one iteration, right? After we need to do what? We will, well, so suppose we have flag that can be specified by the user. Actually, probably not. So by default, if we have a if we have a data, this data is related to the user interface, and the user can set that interface true or false. So if the interface, well, we may call it visualization. Okay. Okay. Let's just set up a property not. Okay, never mind. Let us prepare embedded graphics user interface for our GA operation. So back to this this project. This is a library project, right? So we try to add. Oops, sorry. NuGet. We will add new item. This item is related to the user interface, so we need to select Windows Form. Inherit form, inherit user control, Windows Form. users control, customer control. That should be users control. Okay, I'm sorry about that. So we will name it what? We'll name it what? GA monitor. GA monitor. It's a users control. So you will have a graphics user interface right here. So let me quickly set some property to let you identify the range of this control. So pick color. Let me probably choose this one. So within this this control, we can print in advance. Probably we will have what? We will execution button. We will have probably green, and we will have charting display right here. So the easiest way probably is just add a split container within it, and this part I set into control. Okay, and this part we will add a chart that is related to data, and then we will let it dock CHTGA and set dock property. Okay, and property not dock, so let me set an anchor. Okay, we have a chart, and by default we will have three series ready there, right? So we can in advance set it, and I will let you guys to do that. All right, so make sure, since you are great students, make sure you always has access label, access title for the X and Y. And let me just finish about the series specification. So the chart type is a line. And the second one, third one, for the second, third one, they are also lines. And probably you can say the line one, the name probably we may call it. Well, actually, we have what? We have legend text. We have a legend text specified, right? So legend text let me call iteration. Iteration average. So usually we will make that color. So the color maybe cyan, or maybe green. Iteration average, right? Iteration average. So we'll call it iteration best. So far the best, and I like to make it the color vivid, so I will set the color to red. This one is the color to be blue, lime. Okay. So again, you still can change the name, but the name-wise, it's not very useful at all. And so how about a legend? So we kind of move this legend location. That is legend dock property. Dock to docking button. Okay, so iteration based, you need to specify the access title, okay, and y should be objective value. So we will investigate the convergence behavior or our GA in solving your problem via this charting. Okay, so definitely that should be iteration, and that should be objective value. So you need to specify that, and set some beautiful property for the grid. Okay, because the grid right now it's in black color, right? And the thickness is the same as your line, so it somehow obscure the importance of your line. So try to beautify your chart as possible as you could. And here, maybe we add another split container. You can feel free to do that by yourself, so you don't need to follow the procedure that I have done right here. So orientation kind of change into the horizontal one. So I will put property grid right here and then press the button over there. So roughly we will have button, right? We have reset, VTN, reset, so reset is initially enabled, but not the case for run one iteration and run to end. VTN run one iteration. And the third one should run to end. So initially both buttons are disabled. You are not going to let the user run one iteration before he click on the reset button. So the enability of this button, you should do that by yourself. Okay, I'm not going to do that for you. And within here we have property grid specified. So it's property grid. And let us try to dock it to see if it is okay or not. Not so good. So cancel it. Instead, I kind of set anchor property. Property grid GA. Okay, so this should be our user interface, but right now we kind of embedded this user's control within this library, right? So we have GA monitors ready for us to use it. So who will use it? Our generic GA soul will use it. So GA monitor. So within here, in your GA, we will add, again, this is protected. Actually, we like to set that as a property, right? No, protected. So that is a GA monitor. We call it the monitor. Initially is a none. Okay. Unless the user, the constructor, right here, this is the constructor, right? So we will ask for what? We will ask for a panel. So here, panel is not recognized here within the scope, but you need to include system.windows.form host for monitor. So user does not need to specify it because we have default value equal none. Right? But if user do provide a panel for us, right? So we'll check that. C okay, number okay, up to this point. So if host monitor host for, or let me change the name again, rename it host panel for monitor applied. If host panel for monitor not equal none, then definitely user has provided a panel for us to it. So in that case, we instantiate. So how can you do that? So because initially the control is none, right? It's not, the monitor is none. So kind of instantiate the monitor equal new GA model. So we don't need to provide any parameter for it. But you need to add your monitor to the panel. So host panel for monitor controls is a correction. Add the monitor. Okay, so let us see what would happen if we do provide this kind of panel. So let me, and then not just like that, and also since we have the monitor, right? So the monitor dot ppg probably ppg, you cannot access it, right? Why? If you can remember, right now I do have a public GUI, right? The name is ppg.ga. Why I cannot access? Well, if you look into this source code, open view code. So it's a user's control. So we cannot define a derived class from user's control. So we have a GA monitor right here. And now about the code, all the control related stuff has been specified within here. Right? So your your Spring container, your ppg.ga is right here. But the accessibility is private, right? So private meaning what? Meaning only the function or GA monitor can access this ppg.ga. So how can we do that? Yeah, well, actually you can change the private into public. Then our GA monitor, excuse me, our GA server can access that. Right now, our GA server do have this reference, but I don't have accessibility to access its ppg.ga, right? All right, so how can you easily set it? So let us go back to the design screen. If you click on this guy, if you look into the property setting, there is let me see. There is a modifier. There's a modifier. Indicate the visibility label of this object. By default, it's private. If you set that into public, okay, just this guy is public. Then let us take a look at this class. All right, as you can see, it's public right now. So actually, either way, you can set it via this public grid, or probably you can directly change this accessibility right here. So speaking then, if you don't want to, it says fine. Button to, well, this button should be, maybe we don't need to do that. But definitely the chart, we need to access it, right? So this guy should be declared as public. So then we can access the public grid and access the chart. So naturally we can access the series inside this chart. Okay, so let us go back to our genetic solver. So once we accept a panel object from the main phone, then we add it to it, and then we access the ppgga, right? Okay, the selected object, we can set it to this. Okay, so let us try to invoke this constructor in a different way. So okay, save everything. Since it's an independent project, so we need to rebuild it to see if everything is okay or not. Okay, output right here. Okay, 166 is your failure. All right, so let us step into our program right here. Main phone, right? Within the main phone, we instantiate binary GA, right? So suppose we like to show up the GA monitors in this main phone. So this time I simply add a panel. So don't worry about the panel. Panel is by default the panel, but if you have a split container, split container do have panel 1, panel 2. That panel can be used to invoke this constructor. So right now we have panel 1, and change the name a little bit, PNL GA. So if I specify the back color a little bit to let you see the range of this panel. So right now I have a panel, right? Okay, this panel is panel GA. So when we instantiate an object, I kind of added that PNL GA. Okay, that's it. I think that's all we have. L. What's wrong? PNG, binary GA. Oh, excuse me, I made a mistake. Right? Not mistake. I did not make it complete. So that is the false parameters or the genetic solver. So we need to go back to our binary GA. We need to enhance this guy. All right. So ask for another one. PANER panel. Host panel for GA monitor. Panel is not recognized, right? So we just add this namespace for us, and we simply pass that into our parent constructor. That's it. Okay, so let us trace this code again. So the breakpoint here. So we came to this place, right? Nothing came out, right? Initially, so once we click on it, so we enter this constructor. I think what's wrong here? Anyway, it worked right now. Okay, so as you can see, in your main phone you provide a panel, and then you invoke an so right now user can press this reset normal iteration run to end easier, and then see the progress or the objective value right here from this chart. As you can see, both probably are referring to the same object, right? So if I kind of change this one 0.9, enter, update this guy, as you can see, it will update accordingly. So in this point, we don't need to specify any user interface. We simply provide a panel and then invoke the embedded visual display element. Then we can run our GA right here in your phone. So it's nice. So we don't need this anymore, all right? Okay, suppose it's not an independent it is not independent panel. It still can work. Okay, so suppose I add a split container in here. By default, move the button here. So I intended to let the split container panel 2 to serve as the host panel for the GA GA object. Okay, so click on this guy, fill, dock, select fill. Okay, so it's panel 2, right? So panel 2. So the panel GA, so split container 1, panel 2. Again, that is the panel 2. Okay, I needed to probably no has been deleted, so click on it, run it. Alright, so we have this panel beautified, right? So, but again, we like to use up all the spaces of this panel, right? So let us go back to our embedded monitor and right here, right? So no, excuse me, GS solver. So if a user provide a panel for us, then we add our, so that means user like to have a visualization component, so we instantiate the monitor, and then we add that to the control. And also in here, we needed to special the property, hope the monitor dock, set into docking style field. So we will free up the panel. So take advantage of the parent panel. So don't need it. Okay, that is the idea that we embed the graphics users interface related to the GUI within this library. So user does not need to define any button. So you need to maintain the button visibility within this GUI class library. Okay, so right now we have visualization component ready, right? So you need to take it out. So from time to time, you need to check what? You need to check your GA solver whether you have this monitor not equal none or not. Alright, so we have the monitor not equal none, right? So during the iteration, during the reset, you need to take care about this visualization stuff here. So in our reset function, okay, variable. So before we end up this reset function, if the monitor none equal none, right? So somebody is using, right? So we need to do what? We need to reset. We need to clean up all the data point, right? And also we need to reset the button, right? So so we need to set the button, right? So since that case is required, so we need to access this button to set the visibility, right? Okay, so we needed to reset button run one, and then button run to end, btn run to end. Okay, set these three buttons can be accessed. So change the modifier property here from private into public. Save it. So then we go back to our generic solver. So if the monitor is none, you need to maintain it. So what kind of thing is it? So in that case, if it is reset, so we will hide btn run one. Okay, wait a minute. If it hit reset, Interesting. We need to subscribe. So after reset btn reset the monitor btn reset enable true, but it is hit the reset. Oh, okay, never mind. Since it's reset, right? So after reset, yeah, after reset, actually we need to set the btn run one iteration and enable btn run to end, enable equal true after the reset. Okay. So let us go back to our control. So if we instantiate a controller GA control, but GA needed to, because you see this is the user interface of GA, so definitely we need to implement the reset function right here. Right? Double click it, reset, and then this one should be run one iteration, So the one run to end. Okay, these are the functions should be special within this GA monitor. Okay, up to this point, we have designed our GA monitor, which is a user's control. So right now we need to implement this reset. So from this viewpoint, we needed to have a reference to the GA solver, right? So let us go back to the code here. So this is the GA monitor. So in GA monitor, we need to have a what? Generic GA solver, right? But since the generic GA solver need a parameter, right? So well, this time I like to call it as fine, and I will call it the GA solver. Okay. So the GA solver should be assigned by the constructor, right? By the constructor. So since right now our GA monitor is a normal class, right? Even though it inherits the user's control, we have a graphics display, but it is a normal class. There is no any parameter for the generic GA solver. So we are forced to set our GA monitor class into a temporary class. So we use it as right here. So our GA monitor right now is a temporary class. So similarly, we need to change the code right here. Otherwise, it will fail, right? So we need to do the similar specification. So S is our name. Okay, this is a GA monitor. All right, so where should we specify this GA solver? Right, it says, right? So we have better specify that as a parameter passed in from the caller. So let us copy it. So this GA monitor will receive a parameter, initialization parameter, and then we will set this dot the GA solver equal the GA solver. So we change a little bit about this GA. So from now on, we can, once user click on the reset button, we can say, oh, this the GA solver dot reset. So we can access the function provided in GA solver. So that is the way we like to invoke it. But if you compile it, you will see error coming out because we have changed the GA monitor, right? So we needed to update our code right here. So the GA monitor, generic GA solver, will be associated with a GA monitor, right? So this point is that also definitely we will specify that take the parameter G. So the monitor originally is none, okay? And when we instantiate, we need to use the template. Remember that this class has a template variable t here. So for the instructor, we need to invoke as t. All right, up to this point, I think it's GA monitor t. I don't think there's no argument given that it's from GA solver. The monitor, objective in the monitor, GA monitor, new GA monitor, GA monitor T, the monitor. Interesting. Let me there is not an argument given that corresponding to the required formal parameters. Oh, okay. Because right now we have changed a little bit about the constructor, right? So our GA monitor right here, the constructor we take a GA solver. Wow. So bingo, it will be readily. We need to specify this guy. So remember that GA solver, we are about to create GA solver, right? I mean, in the main form. The main form also provides this panel for us. So during the constructor, GA try to construct GA monitor, but GA monitor need to know the reference of this GA monitor. So simply put this here, and I can bridge this object together. So GA solver right now knowing the monitor know the GA solver. So mutually, the mechanism is not so complicated. But the problem is that right now we have a parameter, right? So it kind of obscure the simplicity of this reference relationship between an object of the GA solver and object or monitor. But it's okay right now. So it's okay right now. So let us go back to our monitor right here, GA monitor. So we have implemented this reset function, right? So the GA solver reset, and how about run one iteration? The GA solver run one iteration. So similarly, like that. So this button are simply for the user interface purpose. So, okay, and since our GA can access the chart and the public directory, so there should be no problem for us to update to add a point here. Okay, so the problem came back to the GA solver right here. So once GA complete an iteration, run one iteration, update's done, right? So it is about the time to check if the monitor non-equal null, so then we need to update the chart. So in that case, GA solver will access that. Okay, the monitor dot chart GA, right? Series, the 0 series should be average, right? The points, we kind of add x, y. X should be iteration ID. How about the y value? Y value should be the iteration average objectively, right? Okay, and then series 1 should be the iteration best. iteration-based objective. The last one should be the so far the best objective value. So maintain this strand. So after one iteration, we need to add a point to our series. But let us go back to reset. Reset, right? Reset. If monitor is not none, right? So we need to add more than that. So the monitor dot chart GA dot series dot 0 dot points clear. Right. So probably actually you can do for each series. It is not recognized, right? Because it is defined within this data position changes. As in the monitor chart GA. So S dot points dot clear. So they are the same. Excuse me, the series correction. Okay, so notice we'll run one iteration. Okay, pretty much it is done here. So I think the rest you should you should design your own logic and implement the functionality in each function by yourself. So graphics wise, I think probably that will be enough. I don't know. Maybe when I implement the rest of the code, I can see whether it is working or not. Okay. So we still can try it out. Reset. Okay, no one iteration. Array sort. Yeah, 15 is value is now, so we have better reset it because we need to have reference. So let us go back to reset. Objective value, 15 is value, new double 3 times size. Okay, let us see. Reset. One iteration. Select the chromosome is none. Okay. Select the chromosome is none. Alright, alright. That should be reset, right? Chromosome. Okay, similarly. Select the chromosome equal new T. That should be population size. Alright. So for R, start from 0 up to population size. Select the chromosome R, T number of gene. So let us try that again. Okay, because we are in debugging mode, so we need to stop it and recompile it. Reset. Temporarily disable it. Temporarily disable it. Alright, run one iteration. Okay. Select objective, yeah, it's none too. Alright. So objective right here, objective. So selected the objective here. part size. Okay, so that is related to the charting. So we have a charting problem. Probably the value is infinity, such that because it's likely that because we did not really update our iteration base, right? So the problem came out from line charting. So let us quickly add that. Okay, so that is done in the GA solver right here. Once we complete an iteration, so run one iteration, if money is negative number, we add it right here. So here in here, I kind of hard-coded this iteration base into probably 5.0 hard-coded to not to let it fail. So definitely you need to compute the iteration base objective, okay? So far the base objective might be infinity, probably not. Iteration average. Average might be 0. Iteration base, iteration average. Well, this guy might be 0. So anyway, you need to calculate this value by yourself. Okay, so I'm here because I just want to make sure the mechanism is working. So I kind of well, so the base should be always 0, so no problem. Not 5.0, probably 6.0. So create GSO and then pop out this monitor, reset, no iteration. I'm afraid that again. So GSO and I put 7.0. Reset, no iteration. Okay, it's working. All right. So the mechanism work. Okay, so but you need to compute those variables correctly in order to make it draw right here. So if you click on run to end, then well, you will run to the end. Okay, so I think that will be the that I won't for the rest of the lab instruction. Okay, so remember that you need to pop up everything in the public grids, and then set category, set description, beautify your charting somehow, and then do the enableability, disability setting for this button. Okay, that's your job.